The area of a circle is found by the equation A is equal to pi r squared, where A is the area and r is the radius. If the radius of a circle is 2.346 inches, what is the area in centimeters squared? Consider significant digits. 1 inch is equal to 2.54 centimeters. So the area is equal to pi r squared. We sub the values, but we are careful that for pi I am going to keep the pi as it is, and for the radius I am going to put 2.346 inches squared. The reason I'm not substituting the value for pi is that I do not need to do so, because I can use my calculator to incorporate the value of pi in my calculation. Be careful that we cannot say that pi is equal to 3.14, because this is an approximation of pi. At the same time, be careful that pi is not equal to 22/7, because if we calculate 22/7, this is approximately equal to 3.142857,143. But if you look at the actual value of pi for the first 10 significant digits, it is approximately equal to 3.141592654. You may compare the value of 22/7 with the value of pi. As you can see, only the first 3 significant digits in these two numbers are equal. Starting the 4th significant digits, these two numbers start differing from each other. Therefore, we pay attention that we should not use 3.14 in a calculation where the number of significant digits is more than actually 3, such as in our problem, and we cannot use 22/7 because this is inaccurate. I also do not need to use the value of pi as 3.141592654, because I can simply on my calculator click the button for pi and produce this number in my calculator. So let's go back to our calculation to calculate the value of A. A will be equal to, according to the calculation we have here, 17.29043375, and as you can see, inches squared. Inside the bracket here we have inches, and we have to square that as well. So the area is approximately 17 square inches. You may note that I have kept many significant digits in this problem, and I am not going to round my answer at this stage. I am going to finish my calculations, and at the end of the day I am going to round the final answer. Now they are asking us to find the area in centimeters squared and not inches squared. So I can continue my calculation in this way. I am going to write that A is equal to 17.29043375, and I can look at inches squared as 1 inch squared. Now we know that 1 inch is equal to 2.54 centimeters, and this is an exact equality. Therefore the area becomes 17.29043375, and in bracket I am going to write, instead of 1 inch, I am going to write 2.54 centimeters, and I'm going to bring the power and keep it. If I use my calculator, I can see that the value of A is found to be 17.29043375. There is a 2.54 inside the bracket, which we have to square, and there is a centimeter which we have to square, and the calculator would give us A to be equal to 111.5509624 centimeters squared. Now, not all of the digits appearing here are significant. We should go back to our original problem and see how many significant digits we had to begin with. Let's see how many numbers we have in this problem. One is the radius of the circle, 2.346. It has radius 2.346. It has 4 significant digits. Then we have 1 inch is equal to 2.54 centimeters. 1 inch is equal to 2.54 centimeters. Here, all the numbers are exact. In fact, when you say 2.54 centimeters, you mean 2.54, the next digit being 0, 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 and so on. So we are sure that 1 inch is exactly equal to 2.54, and if there are any other instruments, this is how it's going to be, and the instrument cannot affect this equality. In other words, all the digits of this number are known, and apart from 2, 5, and 4, they're known to be all 0. Therefore, there are, in fact, an infinite number of significant digits here, or in other words, the number is accurate. And the other number involved was pi. Pi is an accurate number, and we can consider as many significant digits of this number as we want. In this problem, therefore, the number with the lowest significant digits would be the radius, which has 4 significant digits. Therefore, we are going to round our number for the area based on this number of significant digits. I will therefore write that area is equal to 111.5509624 centimeters squared, but with only 4 significant digits. Now, we should consider 4 significant digits. Therefore, we have to consider 1, 1, 1, and 5. And we have to cut off after this 5. But because after 5, we have a number which is greater than, let's say, 500. We have 509. So we have to go and round our 4th digit into a 6. So A becomes 111.6 centimeters squared. So the lesson here is that when you're performing a calculation, such as in this problem, you would have to do all of the calculation and not round any numbers in the middle of the way, and perform all the rounding at the very last stage, when you go back to the original problem and count the number of significant digits and consider the number with the lowest number of significant digits, such as we did.